Okay. As I mentioned, we have two modules left. The first module is structuring the use case model. The second module is prototyping a user interface. So that is it for the semester then. Okay, so as you mentioned, then we have the time left for second ops and all of those things. Yeah, so let me give you an example. What do we mean by structuring the use case model? Structuring allows us to do the following. Where we have our use cases, we've now gone through a lot of the analysis, requirements analysis. We've seen a bit of the picture of where is it going. So what we are looking at is either identifying include use cases, extend use cases, or some form of generalization. What is generalization? Let's start there. It's where we have one general grouping of stuff, but we can then go and form specialized classes or use cases in this case. Now, why would we want to do structuring? Structuring tells us there that it's a matter of factoring out parts of use cases to make new use cases. When you go to an ATM and you have authenticator, let's say you select to withdraw money. What are some of the things that you see when you withdraw money? You select the account, you select the amount. You would also possibly like to see, oh, is there sufficient money? You would want to see the balance. That whole thing about selecting or viewing your balance and quickly just seeing how much money is in that account, does it just happen for the withdrawal use case? If you transfer money between two of your accounts at an ATM, let's say you select the from account and you now want to select the amount you want to transfer from the one to the other. Should it also display to you the balance, how much is available? It should. It should in one way display to you and say to you, you have 500 Rand available to which you can do something with. Either transfer, withdraw, whatever. Okay, so that is a portion of a use case which is repeating itself in various flows throughout the whole system. So if we want to print a basic slip in an ATM, does it happen over and over? For which use cases can you possibly print a slip? Where can we see it? Does it print a slip or ask you to print a slip when you withdraw money? Okay, so it can ask you there. For inter-account transfers, have you transferred money? For payments? What happens if there's not sufficient funds? Does it give you a slip? If you enter your PIN incorrectly, have you entered your PIN incorrectly? Have you done it 3 times? Okay. I've seen people who actually have done it 3 times and it blocks the account and it gives you a piece of paper which says, oh, your account is now being blocked and you need to go to the bank to rectify this. But that matter, is that functionality happening over and over? Was it just happening once? Take, for example, that printing of information can happen in multiple use cases in our whole system. But we are performing it, and what is being printed might be a bit differently. What you are passing to it can be different. So what we are seeing the rest of it says to us, why do we structure this use case model? Number one, to simplify our original use cases. That means to make it easier to understand, to make it easier to maintain, and thereby later on allowing us to reuse that same requirement again. Take for example that printing. Can another use case now use the printing? Yes, it's another portion of sitting there, and it can be used again. Okay, so it allows us to share some functionality between use cases. Okay. Now, there's various ways of doing this. As I mentioned, there's include and extend use cases and generalization. So what you will see, an include use case really tells us it's a relationship which we're going to have from the base use case to the inclusion use case, and it means to us the behavior which is inside this inclusion use case is going to be included in the base use case. You don't really have a choice about do you want to have this happen? Should it happen? Or can you decide about it? No, it is then automatically going to perform it for you. Okay. That is now for an include relationship. So what we are seeing, for example, in this case, where we had our initial use case specification, at some point we might see the words include identify customer. So what it means to us, we have this get quote use case. And then it says to us, okay, go and perform the include use case, identify customer. Then at some point in this use case, once we've reached this step, it's going to jump out and it's going to go through and perform that use case. Then it will return to the base use case get quote for us. So it means to us that we have something like this, where your base use case is going to go through some logic, and at some point it's going to go to the include use case where it says to us, include this use case, let's go through it, going to go through it, and then it returns to the base use case. Okay, so there's a bit more information about why do we factor out this, and why do we use an include use case. It tells us there that we can factor out behavior common to two or more use cases, thereby avoiding describing the same behavior multiple times. Okay, it's not like, it's almost like going and avoiding that we write this section of program multiple times. Am I now going to write the print slip functionality 3 times if it is required 3 times? Am I going to employ people to do it over and over? Or are we going to do it once proper and then call the other, that functionality from where it's required? Okay. So thereby it simplifies the complex flow of event, and we can in factor out portions from it. Okay. Then there's a mention about the extend relationship. In this case, it connects from an extension use case to a base use case, and the extension use case behavior is then going to be added into the base use case if some condition is true inside your base use case. So it's almost like if you select to print a slip. What is true? So you've selected to print a slip. So in that case, it's going to call on a specific extension use case. Okay, so in this case, we are seeing 2 examples where we have the get quote, get news, get expert prediction, and they are extend use cases. So if some option is true in the get quote, it is going to call on get news and get expert prediction. So what we are seeing inside get quote on the left hand side, we are having a place where we have in our use case specification, we have a place which said extension points. In this case, it now says the optional services extension point occurs at step 3 in the basic flow and step alternative flow 1.7 are in get in quote system unavailable alternative flow. So it means to us that that section is going to be performed at some place. Okay. So if we look at that similar egg diagram, what we are seeing is that we have our base use case. If I now made a decision and this decision is true, then it's going to go through this behavior in the extension use case. If not, it still would go through the rest and the remainder of your base use case. Okay, so why do we use an extend use case? Again, it allows us to factor out, in this case, optional or exceptional behavior, and then behavior which is going to be executed only under certain conditions. Thereby factoring out simplifies the flow of event in the base use case, and in that case they're giving a triggering of an alarm as an example. Now it does also add extending behavior to the base use case if we find optional things which we'd like to add later on. Okay. So what they also say to us, it can also be behavior which can be added later on during the development of the system. Okay, so we might get a second version or a second build that goes out, and then we can add in more use cases around specific base use cases. Okay, then there's quickly a mention about concrete and abstract use cases. What we're seeing is our base use cases, in this case B and C are considered concrete use cases. They can be instantiated on their own by some actor, but what we are also seeing is A and D, which is either an include or extend use case, cannot be started by an actor on its own. An actor is going to start the base use case, and then based on some decision or something which happens, it is going to invoke the include or extend use case. Okay. So then there's also mention about why wouldn't we structure the use case model. So what they're saying to us, it really becomes harder to see, especially when we create a very fragmented model, one with a lot of use cases and one with an overly complex structure. So when the functionality becomes very decomposed, it decreases the understandability of the actual diagram in the system. It also increases the complexity of the system and the efforts for your reviewers and people to actually read through the documentation, because now they're reading through one use case, then they're jumping to another. So it makes it a bit more complex to read through and look at. So the next section we have is that we can also have actor generalization, where we have a parent and then children as actors doing separate things. Now, as an example, we might have something like this doctor, nurse, or aide as actors, but what are we seeing from this is that all three of them are still considered medical workers. All the medical workers have the ability to read a chart, but not all of them have the ability to schedule an operation. So only the actual child actor who has the ability to do that can then interact with that specific use case. So there's a bit more information about this. It allows us to simplify the associations between many of our actors and the use case. And then it shows that an instance of a child can perform all the behavior described for that specific parent, and it also allows us to have different security levels. Because, for example, in this case, the doctor can be assigned a different security level in order to schedule an operation compared to the rest. So again, there's a mention about concrete and abstract actors also. So an abstract actor contains the common part of the roles. So the common part in that case would be the medical worker, and the concrete actor can be instantiated. That, for example, is your doctors and the actual specific doctors or nurses we're talking about. So later on you'll see there's an example where they're just talking about quickly the guidelines, use case modeling notation which is used, and then how should we structure the model. We can also develop a small table like this where we can actually then identify and say, I might have an actor and it's communicating with possibly another actor or an actor with a use case. This allows us to simplify later on when we have a very complex structure or complex use case, to take it and to use that information to simplify your use case model. So there's also a few checkpoints on this which you can go through about why would we want to structure the use case model, what is an extend and include relationship, what is an abstract act, and so on. Okay. Any questions quickly? Okay, not this point. So the next section you will see then talks about actually going and designing and prototyping a user interface design. What does it mean to prototype a user interface design? Okay, prototyping a user interface, if we discuss it based on what we're seeing, is we can then talk about actually the user interface, going and looking at defining the navigation map, and then later on to prototype an actual user interface. So what are we seeing in terms of components which can be used in a user interface? It can either be done through some presentation language or some action language which can be characterized as a human to computer interaction, something which you are either going to click a button or press a button or select something to make the computer do something. Presentation language is what the computer is going to display to us possibly. Okay. So we are going to look at quickly developing a navigation map and then also user interface prototypes. Now you'll see a navigation map really helps us to identify the primary user interface elements. Okay, so those are the windows that are central to the user's mental model of a specific system or even use case. Okay. So it is the windows that the user will spend the most of the time on, and that will provide the initialization for some use cases. If we had to quickly draw the section, what would we see to authenticate someone? If you had to sign into ITS, what do you see? You see a text box, or two text boxes possibly. What else do you have? We might have some text. What text do we have? The one would say to us, student number. That one would say password. Then we might have a nice big button sitting there, which can say login. Is this a prototype? Is this a prototype of a user interface, guys? So what are we seeing? Yes, this is a prototype. It is a possible screen which we can have for a page where someone can authenticate and use the system. Okay. If you get to an ATM, what is the functionality which you can have in an ATM? Okay, that one would be to insert the card. But now let's say you have already authenticated. You are inside the system. What can you do when you arrive at that screen? So the first screen will allow us to enter the PIN. Okay, is that what we see on the user interface? Don't we see some section about cancel? Oof. Is that things which we see? Possibly, yes. Okay, so when we look at this, when we're defining a navigation map, how does that relate to a user interface prototype? Now, for a navigation map, we can start to identify pages and say, but in an ATM, what are we going to have first? Place where we are authenticating. So that first page must allow me to authenticate. Where am I then going to go? We can go and say we are on the home screen. From there, where can we go? We can select to transfer money. So we can select withdraw. On the withdraw, what options do we have? You see, we can start to break this down. And this starts to form a navigation map. Once I authenticate, I'm going to go to the home screen. From the home screen, I can select to withdraw. I can also select to do a payment. So those are things that we might have, and then from there on we can branch it again and say, but you've selected to do payment. What type of payment? From which account do you want to pay? How much do you want to pay? Okay. So those are things which we might have to consider for the navigation map. Now, you'll see a navigation map can be represented in different ways. It can be done as a hierarchical tree in some form of diagrams where we can start and we can then start and say, but I might have my highest level here. Where I have my home screen, like 1. What can I then do? Home screen. I can withdraw. So we can continue breaking it down and create some hierarchical tree structure. Or we can have a free-form graphics with custom icons. That's almost what we've done a bit earlier. Or we can go and use a UML class diagram where each of the classes represents a user interface screen which we are going to see. Okay. So things which we might keep in mind that when developing the user interface, that it must match, the user interface must match the task which is going to be performed. Okay, so where will we see that? We must go and look at our initial use case specification also. Then to design an efficient user interface for it and get appropriate feedback from users so that they have the ability to test it and say, but yes, this works or this does not work. Then to generate some usable queries and to improve it later on for some productivity to see how can it be optimized later on. Okay. So a prototype can be developed in different forms. It can be done in a natural language user interface, question and answer user interface, menus, form fields. So there's different types of user interfaces which we can have. But you'll see things which we might consider when we're developing the user interface is the visual design of our primary windows, the user actions which is going to be related to those primary windows, and then some miscellaneous features which we might need to incorporate. Does it need to handle the playing of sound or certain features which we might need to incorporate? Okay. So there's a few things which we might need to consider and which we can incorporate into our design of our primary windows. We must keep the user interface or the interface simple, not make it overly complex. If you look at that ATM structure, you have basic options on the left and a few on the right hand side, where you have buttons on the side to make a selection of it. Then you must create some consistency and use a common user interface elements in order to perform it. And then be purposeful in your page layout in how you are arranging these elements. And then the strategical use of color and texture in terms of your layout and your windows, to not make it difficult for someone to read it. Okay. Then to use a proper typographical fonts and arrangement of your user interface. Also to ensure that the system communicates properly with the user what is happening. Okay. So not that you've clicked and later on the user is wondering what is happening now, that you give them proper feedback in that whole interaction. Then there's also ability to even incorporate defaults and default values into the system. Things which might need to be considered in that case is, are you going to have default values which will be assigned? Let's say if you are going to transfer money, what will be the default date? Are you going to do it from today, and the default money which we transferred? Okay. So things which we can have on a user interface, and it's not just limited to this, we can have some input controls. This can be buttons or text fields and checkboxes, radio buttons, drop-down lists, lists and toggles and date fields. Those are allowing us to input some data. Then there's navigational components where we can have breadcrumbs and sliders and search field, and then we also have informational components, which is our tooltips, or icons, or progress bars, which gives the person some feedback on where they are currently. Okay. Then they're quickly talking about other miscellaneous features which can be incorporated, which we might see, and the decisions which we might need to make is, for example, how are we going to support window management? Can we have multiple windows open at the same time? Okay. Is there going to be session information which we need to keep or even store? Do we need to have a scroll bar or a window that tells us, take for example, what do we see in Blackboard? Do we need some contextual scroll bar or breadcrumbs at the top telling us you are currently here? Okay. And then are we going to support a single or multiple document interface for our Pramac windows? So we can also then use proper feedback and give this to a client and say to them, this is what we envision for the user interfaces. Now, as we've done the user interfaces like earlier on, something basic like this. This is still considered a user interface prototype. It can be done on paper, can be done using a complex software and modeling and all of that. But the idea is mainly that you spend as little amount of time on it, that you actually get going and you give it to the client and say to them, this was what we see, and you can take it forward from there. It's not designed yet, so it can be corrected still. Okay, any questions, guys?